Hello guys, this is Prime Concept. In this video, we want to consider a very simple and very important topic, indices. Now, why do you need to learn indices? Indices is one topic that would help you in virtually all the topics you'll be studying in maths, particularly if you're studying calculus. You would really need the knowledge of indices so you can handle calculus very well. So I'll be teaching you in this video the rules that you need to know. Indices is all about rules. So if the concepts behind the rules of indices are clear to you, then you can solve any problem in indices. Trust me, by the end of this video, you'd really be amazed at all the things you would have learned under indices. So do well to stick with me in this video till the end, and you'll be getting the concepts and short ways for approaching exam problems. So what do we mean by indices? Indices, I would say, because indices would mean plural. So when we say index, that is the singular for this. So index is the number of times to which a number, which is the base, is multiplied by itself. Index simply means the number of times that a number is multiplied by itself. Let me write it. In this index, which you can call it power, you can also call it exponent. So index is the number of times to which a number, and this number is usually called the base. The number of times to which a number, which is the base, is multiplied by itself. So take note, not by another number, but by itself. So the number of times you multiply a number is what we denote as index or indices, or what you know as power or exponent, while the number that is being multiplied is the base. So a simple notation for this is a raised to power n. So this simply means that you are multiplying a n times. So in this particular notation, n here means the index. N is what we call the index, or the power, or the exponent, while a in this case is what you call the base, right? So n, which is the index, tells you the number of times you are multiplying the base. So if I have something like, say I have, let's say, 2 raised to power 3, this simply means that the index is 3, the base is what? 2. So it means that I am multiplying this base 2. I'm multiplying it 3 times. So this can be written as 2 times 2 times 2. So it means I'm multiplying this base 3 times. So if you see something like 2 raised to power 4, this simply means I'm multiplying 2 by itself. How many times? You are very correct, 4 times. So I would have 2 times 2 times 2 times 2. So I'm multiplying it 4 times. So that is just what indices actually refers to, the number of times. So quickly, the next thing we want to look at are the rules that governs indices. And these rules are things that once the concept is clear to you, then you can solve any problem under indices. You would be learning the different types of indices that we do have. You'll be learning things that you should not, mistakes that you should not make in indices, and that is why you should stick with me in this video. So let's consider the rules in indices. So number one rule we want to consider is the multiplied power rule. Multiplied power, or you call it product of power. Multiplied power, or you call product of powers. So if we have, say we have a raised to a power n, and we are multiplying this by a raised to a power of m, And one of the things you should have noticed first is that our bases are the same. So this rule is applicable when you have common base. Now when you have a raised to power n or a exponent n multiplying this, then this would be given as a raised to power n plus m. So you add their powers. So when you multiply two indices with the same base, you add up their powers. So a quick example would be, say we have 2 raised to power 3 times 2 raised to power 2. Now because these bases are the same, this is 2 and this is also 2. What do I do to their powers? You are very correct. I will add them up. So I will have 2 raised to power 3 plus 2. This would now become 2 raised to power what? 5. Right? Yes, and you can decide to still expand this. And let me give you another one that looks a bit tricky. And say you have 2 raised to power 3 times 8. Now you would clearly see that we no longer have same base, but then something will tell you that 8 can actually be written as a base of 2, right? So let's do that. So this can be written as 2 raised to power 3, which is this, times, now 8 can be written as 2 raised to power 3 also. So that this becomes, because their bases are now the same, I can then add their powers. So this becomes 2 raised to power 3 plus 3, which is 2 raised to power 6. So you see how you can simplify. So indices is really very important. So quickly, we want to look at rule 2. Rule 2, which is what we know as the quotient rule. So of course, with same base. We have quotient rule with same base. Now say we have a raised to power n divided by a raised to power m. Now you would still notice again that their bases are the same. So this is a, this is a. So when you have something like this, of course you should know that this line means division. So I can write this also as a raised to power n divided by a raised to power m. So these two things are still the same. I've not yet applied the rule. But what does the rule say? The rule say when you have division quotient like this, then the power below can come up and you'll be subtracting. So this would simply be a raised to power n minus m. Why minus? Because m is the one under. So if you say a raised to power m minus n, you'll be wrong. So it has to be the power above subtracting the power below, right? So this is very important for us to know. Now let me give a quick example on that also. Now say you have a problem like this. You have 8 divided by 2 raised to power 2. Now say we have this, of course there are so many ways to do this, but let's go the way of indices. Now this would simply be 8 can be written, we just saw that, you can write 8 as 2 to power what? 3 divided by what now? 2 to power 2. So that since your bases are now the same, 2 and 2, you can subtract. So I have 2, I will first write the common base, then I'll start with the power above, which is 3. Then the one under would be subtracted, so minus 2. So I have 2 raised to power 3 minus 2 is 1. And of course, 2 raised to power 1 is still 2. So this is what we have. So we have looked at 2 rules so far. Now we want to look at product rule again. Number 3 now. Product rule. Right? Now say we have a raised to power a times b, this product now, raised to power n. So you have two bases multiplying each other and they have a common power. So this would simply be, you can write this as a raised to power and you can distribute the power. And then you have b raised to power what? And this is a very important rule, too important, right? Yes. So it just tells you that you can distribute the power amongst them. And you can go from here to here, you can go from here to here, depending on what you want to achieve. I will give a problem that will help you see this. Now say you have example, say you have 2 times 3 raised to power 2, and you see that you have product, right? Yes, I can distribute this power amongst them. So I would have 2 raised to power 2 times 3 raised to power 2. So that this would give me 2 raised to power 2 is what? 4 times 3 raised to power 2 is what? 9. So that when you multiply this, you have what? 36. Right? So you see it works. If you do go through this way, you still get the same thing. 2 times 3 is 6. So you can say 6 raised to power 2. 6 raised to power 2 is what? 36. Right? So you see it's true. Now let me give you an application of this rule so that you see how important it is. And let's say you have 2 raised to power x times 3 raised to power, okay, let me say 4 raised to power x times 3 raised to power 2x equals 6. Okay, let's say this. And say you have this kind of problem and you are required to find the value of x. So what are you going to do? Very quickly, you would notice that the power of this 4 is x, the power of this 3 is 2x. Now, is there a way I can get a common power? Of course, very possible. So you notice that 4 can be written as 2 raised to power 2. So I would have 2 raised to power 2, which is for 4, right? Yes, then I would have x, though I've not mentioned this rule, but it's very simple. So times, what do I have now? 3 raised to power 2x. This is equal to 6. Now, when you multiply this is a rule which I will mention after this. So this times this will give us 2x. So I have 2 raised to power 2x times 3 raised to power what? 2x equals 6. Now, what are you observing? We have common powers. So common powers, just like in this case. So if they have common powers, what do? You can multiply both of them and bring the power out. So I would have 2 times 3, I can multiply, then bring the common power out, which is 2x. Then this I would equate to 6. 2 times 3 is what? 6 raised to power 2x equals 6. I can write this as power 1. So that seeing that our bases are now common, I can equate or compare their powers. So I would say 2x equals 1, so that x becomes 1 divided by 2. So x is 1 over 2 by applying this rule. So you can see how important this actually is. So let's move on. We've looked at 3 very important rules. So let's give the next one. Quotient number 4. Quotient with different base. So we have quotient with different base. So how do we handle that? Now, what is the rule? The rule is simply saying that if I have a raised to power n divided by b raised to power n. So you notice that my bases in this case now are different, unlike rule 2 that I gave. My basis for this is no longer a and a, this is a and b. But what is common for this is their what? Powers, while their bases are what? Different. So this can be written as a divided by b, all raised to power what now? N. So you can combine their powers. So this is a very important rule. So just like we did in the previous one in the product. So this is important. So number 5, rule 5. We call that product of powers. Product of powers. Now say we have a raised to power n. I've used this anyway, but let me still mention it. So say we have a raised to power n, then all raised to power n. So their powers can be multiplied. So you have n times n, which is nn. So I would have a raised to power nn. So you can multiply their power. So this is a very simple rule, just like we did. So you have, let's say, 4 raised to power, let's say 4 raised to power 2. This can actually still be written as 4. You can still simplify 4. So you would have 4, which is 2 raised to power 2, then all raised to power the 2 that is outside. So that this 2 raised to power 2 will still give us back our 4, right? Now, how do we simplify this? By applying this rule, I can multiply the power. So 2 times 2 is 4. So I'll have 2 raised to power 4. So I've applied this rule. So let's look at the next rule, rule 6. Negative index rule. Negative index rule. Say I have a raised to power minus n. So you can say I have a negative power. So this can actually be written as 1 all divided by a raised to power n. So this is true and very important, especially when you're dealing with differentiation. So you'll be needing this so well. So this is it. Now say we have fractional power. Number 7, fractional power. Fractional index or power. Now say we have a raised to power 1 over n. This is a fractional power. So a to power 1 over n, you call this nth root in mathematics. So this can be written as the nth root of a. So this is true, right? Yes. Now what if what you have here is no longer 1? So you can still have fractional powers like this, a raised to power m over n. You can still have this. In this case, this is no longer 1. So if you have this, what would it be? It's going to be the nth root of a, then you use your bracket and then include this power n. So this is what you would have, right? So you take note of this fractional power rule. Then we have rule 8. Rule 8 is what you know and some of you have been waiting for. The zero power rule. Rule 8. Zero power rule, right? Yes, zero power simply means you have a raised to power 0, right? In this case, you're going to have 1. A raised to power 0 is what? 1. You have 2 raised to power 0, what will it be? 1. 3 raised to power 0, what will it be? 1. 4 raised to power 0, what will it be? 1. 5 raised to power 0, what will it be? 1. 1 raised to power 0, what will it be? 1. So at this point, I think we should prove this because it's very easy to prove. Very simple. Now, say we want to show that a number, with the exception to 0, infinity, and a few others, so a number raised to power 0 is 1. We want to prove this. Now, you have a, if you recall, say you have a raised to power n divided by a raised to power n, common power. And this can be written as a raised to power n. Because of this, remember what we said about quotient, this power will come and be subtracted. So you have minus n, right? Now, remember that this divided by itself, a number divided by the same number will give 1. So this already divided by this would give us 1. So that you have this, which is same as a raised to power n minus n. subtracting a number from the same number, what will it give us? 0. So that we can now say that a raised to power 0 is equal to what? 1. So this is rule 8, which is very important. I want to add another one. Rule 9. Rule 9. I'll say you have this. You have A over B. We already saw this, but I want to still give it separately. And say you have A over B to power minus 1. A over B to power minus 1. This can actually be written as what? This can be written as B over A. So A over B to power negative 1 can be written as what? B over what? A. So this, I believe, is clear. Now, I want to point out a very important thing you would have noticed in the course of solving problems or applying this rule. I've mentioned two things, salient points. I want to pronounce those points now because they are very important in indices. Now, there are 2 points I want you to note. Points to note. There are 2 points that governs everything we do in indices. These 2 things guides everything. When you know these 2 things and always look out for these 2 points, then you can solve all problems together with the rules. Now, what are the 2 things you need to know? Number 1 is that whenever you are given a problem, first thing you always check, find a common power. Okay, let's start with this. Find a common base. Anytime you are given any indices problem, you look out for, can I get a common base in this problem? So number 1, find a common base. Find a common. Now, these 2 points I want to mention, one of them must be possible always, or the 2 of them can be possible. At least one of them will be possible in every problem so that you can solve. So find a common base. What do I mean by this? Say you have 4 raised to power 2 times 8. Now say you have this. You would notice very quickly, for you to be able to solve this, the first thing you want to think of is, can I get a common base in this problem? So that is one of the first things that should come to your mind whenever you have an indices problem. So you try to locate a common base. So solving this, you know that 4 can actually give me a base of 2. 8 can also give me a base of 2. So knowing that, I can simplify this problem. So this can be written as what now? 4 is 2 raised to power 2, then to this power 2, right? Times 8. Now 8 is same as 2 raised to power 3. Did you notice I've gotten a common base? Yes, that is the basis for solving indices problem. So that if you simplify further, this 2 times 2, which is 4. 4 plus 3 is 7. So I have 2 to power 7. That is number 1. Then number 2 point you should note is that whenever you're given problems under indices, then the second thing is where a common base is not possible, then you find a common power. Find a common power. Find a common power, or what you call index, or what you call exponent. Find a common power. So any problem they give you in indices, there must always be a possibility of any one of these or both of them. So it will, if it's not possible, then you can't solve the problem again easily. Now, so what do I mean by find a common power? Now, just like in the problem we solved, I give something like 4 to power x times, I think 3 to power 2x equals 6. I gave a problem like this. Now, you will notice that the bases are not the same, and there is nothing you can do to make 4 and 3 the same. It's not possible. So once you check, seeing that your bases can no longer be the same, what's the next thing that should come to your mind? You are very correct. You think of getting a common power. So seeing that 4 and 3, no matter what you do, they can't be the same, then I look at the power. The power here is 2x, while my power here is x. Is it possible to make this power x? That is the next thing you want to think of. Of course, to make this power 2x. Is it possible? Yes. Seeing that 4 can be written as 2 raised to power 2, so that you can then write this as 2 raised to power 2x times 3 raised to power 2x. Did you notice you have a common power here now? Yes, and with this common power, just like we did, you can now solve this problem. So these are the things you always look out for when you're solving indices. So do well to note these points. They are very important. Then before we start solving problems, the last point I want to mention now is the types of indices you would have or you would always meet. Types of indices. A lot of people don't know that we have different types of indices. So they are just familiar with the basic one, you know. But we can meet 3 types of indices when we're solving problems. Number 1 is indices leading to linear equation. Indices that are leading to linear equation. Look, this is one of the easiest that you would always meet, which is common in exams. So indices, of course, you know, linear equations are equations where the power of x is 1. So these are linear equations. So indices leading to linear equations. How do you identify indices leading to linear equations? They are always, the basis for this kind of problems are always separated with multiplication or division, or they are just equated to each other. Take note of it. The bases are usually separated with multiplication or division, or you just see that the bases are equated to each other. You don't see addition or subtraction separating the bases. They are always separated with multiplication or division, or they are equated to each other. Let me show you what I mean. Say you have 2 raised to power 3x times 2, say times 2 equals 4. Now say you have something like this. Now you would notice that this basis, what is separating them? Multiplication. So whenever you have this kind of problems, then these indices, and then the power of x is 1, then these indices would always lead you to what? Linear equation. So it's very simple to identify. So when you see multiplication or division separate, this is just a simple way, a layman's way of knowing this, even though there might be more to it. But take note of this. Now say we have this problem. Let's quickly see how we can solve this problem. Now this can be written as 2 raised to power 3x times 2. 2 can be written as 2 raised to power 1. So this is equal to 4 can be written as 2 raised to power 2. So when you have this, because these bases are the same, what do we do here? We can say 2 raised to power 3x plus, since you have multiplication, what do you do to the powers? You add them, plus 1 equals 2 raised to power 2, right? Now since I have common basis, what do? I can equate my powers. So if I do that, I would have 3x plus 1 equals 2. So that this would give me 3x equals 2. When this crosses, it becomes minus 1. 3x equals 2 minus 1 is 1. Then x becomes 1 divided by 3. So you see, I've been able to, you can see that this is a linear equation. So these are the number 1 type of indices you would meet. Indices that are leading to linear equation. So number 2 you would meet. Number 2 is indices leading to quadratic equation. Indices leading to quadratic equation. Indices leading to quadratic equation. So that is number 1. Now, how do you identify this kind of indices? It's usually common in exams like WAEC, 100 level university students. You'll always see this type of indices. They always come. So, and it has one pattern, one way in which you can solve it, which I'll be doing in this video. Now, indices leading to quadratic equation, you can identify them. You would notice that their bases are usually separated by addition or subtraction. So you would see the basis. You have addition between the bases, no longer multiplication. Addition separates two or more of the bases. Now, what do I mean by that? You have something like this: 2 raised to power x plus 2 equal to, let's say plus 2 plus 2, let's say 2 raised to power 2x plus 2 raised to power x equals, let's say, 4. Now, when you see this kind of problem, very easy. You see that what is separating this index and this one, what is separating them is an addition. So when you see this kind of problems, you should know that these problems would always lead to what? Quadratic equation. So how do we solve this kind of problems that are leading to quadratic? I will show you. So after explaining the 3 types, then I'm going to give a problem that would lead us to linear equation, quadratic equation, simultaneous equation. Then I'll close the video with that. So, but you should know that whenever you see index like this separated with addition or subtraction, it would lead you definitely to quadratic equation. Then number 3, which is very easy to identify, is indices leading to simultaneous equation. That is number 3. How do you know that a problem is a simultaneous equation problem? Whenever you have 2 unknown, when you have 2 or more unknown, then it is simultaneous. Of course, for the simple scenario we're looking at, you'd always have 2 unknown, x and say y. So whenever you have indices and if you notice in your powers you have 2 unknown, x and maybe y, then you should know without thinking that that question would lead you to what? Simultaneous equation. So something like this: say you have 2 raised to power x plus y equals 4. They would always give you 2 equations also, you should know. So when they give you this, it's not enough because you already have 2 unknown. And they might give you, say, 3 raised to power x plus 2y equals 9. They can give you something like this. So you don't need a soothsayer to tell you that this would lead you to what? Simultaneous equation. Why do you know that? 1 is that you have 2 equations you're solving at the same time. 2 is that you have 2 unknown, x and y. So this would lead us to simultaneous. So what we're going to do now, I'm going to drop a problem, about 3 problems that will help us learn these 3 different types of indices, and then we end the video with a very important exam tips. If you have watched this video up till this point and you are yet to subscribe to my channel, please do well to hit the subscribe button. This is your own way, great way of showing me your support. Then like this video, comment, and share with 10 of your friends. Tell them that this is Prime Concept. So let's take a look at these 3 problems very quickly. Alright, so we want to consider these problems. We want to solve these examples, right? And then we'll continue with more examples in the next videos. And the first one says 3 raised to power 4x is equal to 27 raised to power x plus 3. So in all this, we want to solve, in this first case, we want to solve for x. Second case, we want to solve for x. Then the third case, they say solve for t. We want to solve for t, right? Now, very quickly, let's start with the first thing. The first one is 3 to power 4x equals 27 to power x plus 3. Now, I mentioned that whenever you're solving problems under indices, 2 things should always be at the back of your mind. Number 1 is find a common base where possible. If it is not possible, then number 2 is you find a common what? Power. One of them must be possible. So let's start by checking. This is our base 3, which is the simplest form, you can't reduce 3 any further. But let's check. We have 27. Can you reduce 27 so that you can have 3? Very possible. So quickly, I can find a common base in this case. So I'm not so interested in the common power. So I have 3 raised to power 4x equals 27 can be written as 3 raised to power 3. Then I have my bracket all to power x plus 3. Now I have 3 to power 4x equals, now this, from what we have learned, this power can multiply this. So don't make the mistake of using this to multiply only this. This is multiplying the 2 you have outside. So you have 3 times x is 3x plus 3 times 3 is 9. So don't forget. Now you notice we have a common base. So since I have a common base, what do? I'm going to equate their powers. So I would say 4x is equal to 3x plus 9. So that when I bring this to this side, I would have 4x minus 3x equal to 9. 4x minus 3x is just 1x, which is equal to what? 9. So it means that in this first question, the value of x is what? 9. So is that true? Of course, yes. If you replace 9 here, you would see that the two sides of this equation would be the same. So this is how you can solve the first problem. So let's take a look at the second problem we have here. So number 2. Number 2 says a divided by b all raised to power x. This is equal to b divided by a all raised to power x minus 3. Now, you would notice something also. Our bases are almost the same. In this case, what is your base? Your base is actually this whole thing, a over b and b over a. This is your base. That whole thing in the bracket is your base. So your base is not just this. So I can solve this problem in so many ways. So let's go, maybe I'll do in 2 ways. But let's go in this method first. Now, very quickly, since this is a over b, I can actually make this to become b over a, just to look like this. So, but if I'm switching these numbers, if I'm taking a down and bringing b up, it means I should include a negative in the power, just like a rule I gave you. I told you in one of the rules that a over b raised to power minus 1 is same thing as b over a, right? Or you can say b over a, same thing as a over b to power minus 1. So it means once I change a base, I add minus to it. Once I change a base, once I invert, I add a negative to the power. So this is by the way. So this, I want to make this b over a. So I'll have b over a. Then what do I add to this power? I would add negative x, right? Then this is equal to what now? B over a. Then what do I have? I didn't change this, so it remains b over a, b over a. So I still retain my x minus 3. X minus 3. Now, since I have a common base now, which is b over a, b over a, what it simply means is that I can equate my powers. So I would have minus x equals x minus 3. So very quickly, I'm going to take this minus 3, I'll bring it to this side so that when it crosses, it becomes 3. Then equal to, this is remaining here, x. Now when this minus x crosses, it becomes plus x. So I have that 3 is equal to 2x. So how do I find x? I'll divide both sides by 2. Divide by 2 so that this would go. This would now imply that x is 3 over what? 2. So this is my answer. Is there a different way for solving this? Of course, yes. I can decide to distribute this power. Let's try it and see. Say I don't want to go this way, which is the fastest. But say you decide to distribute the powers. Let's see what we'll get by solving like that. So I can distribute this. I can say a to power x divided by b to power x, right? I've distributed the power. So this would give me b to power x minus 3 divided by a to power x minus 3. I've distributed the power. So what's next? I can cross multiply. So I cross this. So I would have a to power x times a to power x minus 3, which is equal to what? This multiplying this, b to power x times b to power x minus 3. So what do I have now? Since I have common base, I can add their powers. So I'll have a to power x plus x minus 3 equal to b to power x plus x minus 3. So what do I have now? I have a to power x plus x is 2x minus 3 plus b to power 2x minus 3. So what do I do from here? Very simple. I can divide again, divide both sides by this. So I would have a to power 2x minus 3 divided by b to power 2x minus 3. If I divide by that, I'll be left with 1 on this side, right? Yes. So that I have, I'm sure you can already see where we're going to. So that since I have a common power from what we know, you can combine it. So I can say a over b to raise to my common power 2x minus 3 equal to 1. Then I have a over b 2x minus 3 equal to, from what we have learned in indices, any number can be written to power 0 to give us 1. So since I have a base of a over b, instead of writing 1 here, I can repeat by saying a over b, then raise this to power 0, so that you know that a over b to power 0 will still give us this 1. So have we changed it? No, we have not. So what do I do now? Since I have common basis, I can equate my power. So I can say that 2x minus 3 equal to 0. Then I would say that 2x is equal to 3, and then x is 3 divided by 2. So this is still the same result. So which of these methods do you prefer? Drop the answer in the comment section. Now, number 3 question. For the sake of the length of this video, I'm going to solve number 3 question in my next video. So do well to subscribe to this channel so that you'll be notified when I post the next video. Thanks for always watching. Thanks for always supporting my channel, Prime Concept.